So first for your homework, the question is asking you to calculate the mass, use the kilogram. But everyone, I don't know why, just using the mole. You should transfer the mole to kilo. Yeah, to kilogram. Okay. Yeah, the question is how much kilogram. Okay. So you need to transfer the mole to. So how to calculate their mass with kilogram. The homework. How to do? You just calculate the mole number, right? How do you change the mole number to kilogram? Yes, the time is mole mass. Okay, mole mass, and then you get the kilogram. So this is the homework. Okay, so today we will learn chapter 12. So it's about the transition metals and coordination chemistry. So basically, coordination chemistry is very important in chemistry because for metals usually they tend to form the compound. So this is about the coordination chemistry. So in this chapter, we will introduce the coordination compound, and we also do the isomers. Third one is about the bonding in complex as, and we also simply introduce the biology, the importance of coordination complexes. Okay, so what is the compound? What are the compounds? So basically, compounds means, for example, for metal compounds, they have two parts. One is metal ions. Another part is ligands. So for the metals, we know, for example, the position. We can, from the table, we can see the position of transition elements on the this periodic table, right? So basically, they are in this. So how to call these metals? Yeah, transition metals is all D block. Okay, D block metals. And besides the D block metals, we also introduce landslides, right? Inner metals, inner transition metals, is called the landslides. So all these are transition metals. So now the coordination compounds, we know they are made by two parts. One part is metals. So in the compound, all the metals can be in the compound, compounds. Okay, so the first part is the metals. And another part is about ligands. We call it ligands. Like for example, this is a complex. This is a compound. And the center is the metal, right? And it coordinates with 6 ligands. 6 ligands. Okay. So this means they form a complex. So between the metal and the ligand, So there are bonds formed. Okay. So the bonds, what's the bonds? The bonds are called coordination bond. Coordination bond. Okay. We know bond, right? So for example, in a compound, there are like carbon-carbon single bond, right? Carbon-carbon double bond. Okay. Yeah. So this bond is called coordination bond. So they are formed between the metals and ligands. So the ligands can be neutral, small molecule, or can be some anions. Okay. So, and for the couple, we know they may show different oxidation states. They can show like a +1 charge, +2 charge, or +4, 3 charge. Okay. And cations is here is metal ions, right? Metal ions are often complex ions where the transition metal ion is surrounded by a certain number of ligands. So these ligands we also call them like Lewis bases. The ligands, why we call them Lewis bases? Because they can provide electrons. So we know the metal has some empty d orbitals, right? D or F orbitals, they have some empty. So these empty orbitals can accept the electrons from the ligands. So this is when the metals accept electrons from ligands, like two electrons here. So between the copper and the ligands, there are 2 electrons. There are electrons. Okay, so this means they form coordination bond. We know, for example, carbon-carbon single bond. They also, for 2 carbons, they share 2 electrons, right? Between 2 carbons. In this case, they also should share electrons. Basically, they also share 2 electrons. So the ligands can provide electrons. So, for example, in this case, the nitrogen, we know the nitrogen has no pairs, right? There's no pair electrons. So these no pair electrons can be shared by metals. So they form coordination bond. Because the ligands can provide electrons, so we call them Lewis bases. And so the metal. So what's the metal? The metal can accept electrons, right? So they called Lewis acids. So the metals can be called the Lewis acids because they can accept electrons, because they have empty d and f orbitals. So this empty d and f orbitals can accept electrons from the ligands. Okay, and the ligands has, for example, this ligand has the no electrons. So you still know the word no electrons, right? Because the nitrogen, we know N nitrogen is the electron configuration is 1s2, 2s2, 2p3, right? So 2p3 form 3 single bond with 3 hydrogen, right? It still has 2 electrons in 2s2, right? So these 2s2 electrons can be shared by the metal, So they form the covalent bond. Okay. So after they form the covalent bond, so they form like complex. They form a complex. This is called complex. Okay. So basically, the cations are often complex ions where the transition metal ion is surrounded by a certain number of ligands. So this is about the complex. Okay. So we can also use this way to this picture to show the complex. So now you know what is complex, right? So complex basically the center is metal and it is surrounded by some ligands. And the ligands provide electrons shared by ligands and metal. Okay? So for example, this here are 3 complexes. You can say compound. So here, so basically, what's the difference between the, sometimes we say the complex, sometimes it's the compound. So what's the difference between the complex and the compound? For example, the whole molecule is called compound. Okay? But this part is called complex. Okay? So here we can see, but sometimes complex is also compound. So 1, 2, 3, for these 3 samples, which one has the same name of complex or compound? Which one? No one. Because here, no, I will give you an example. It is compound. It also can cause complex. So the whole molecule is compound. Okay. But only this part is metal and ligands. Okay. Metal and ligands, they form a complex. So this part is a complex. So in this part, we can see the copper is +1 charge. Okay? The ligand is neutral, right? So the whole complex is +3 charge, right? 3 plus charge. So this complex is 3 plus charge. And of course, there should be some angle outside, right? Because the whole compound should be neutral. But this part is not neutral. So the outside may be like 3 chloride. Okay? Because chloride is -1 charge. So it has 3 chloride. It also the outside is surrounded by 3 chloride. It's like sodium chloride, right? The sodium is +1 charge. And of course it should be combined with chloride. Okay. So in this case, say this is 3 plus charge. So the outside should be 3 chloride. So this part we can say like this. You should write this is 3 plus. Okay. So here we can say, so in this formula we can say what is the charge of this part? What is the charge? Because the whole molecule should be neutral, right? So what charge of the complex complex part. Outside is 2 chloride. So inside, so this part, what's the charge? Plus or minus? Plus, yes, 2, yes. So this part must be plus 2 charge. Because outside, we know outside is minus 1, so 2. So this guy should be plus 2. Okay, so for this is plus 2, and now we can figure out the charge of the metal. We know this is neutral, right? So this is a minus 1 charge. So what's the charge of the metal? The whole must be plus 2, right? This is the minus 1. So this is neutral. Neutral is 0. So what is what charge of this guy?
Plus 3.
Yes, plus 3. Yeah, because it's plus 3 and minus 1. So yeah, minus 2. Okay, second question, second sample. Tell me what the charge of the iron. We know this is the neutral. Okay, this is the neutral. Yeah, what? Or monitor, who is more close to the you? So what charge of the metal in this compound? This is the whole stuff is compound, right? This part is complex. This part is complex. So what charge of this guy? Yeah, minus 2. So the whole stuff must be plus 2, right? But here is 2. So this complex, the charge, what is the charge of this complex? Minus 1?
Well, I said that because with those 2.
Yeah, yeah, but if this is a minus 2. So here should be minus or plus?
Plus
Yes, plus. How much?
4.
Yes.
4?
1.
Yes, 1.
That's what I said.
You say negative 1.
No.
Yes.
Where? Yes.
You say negative 1. You do say plus 1. Okay, now if this guy, the complex is plus 1. Okay, so what charge of this iron? Hey.
The complex is plus 1.
Yeah, the complex is plus 1. And we know this is neutral. En is neutral. And what's this? This is minus 1, okay? This is minus 1. So what's the iron? What's the charge?
Plus 2.
Plus 2? Correct?
Wait, you said that the one inside there is minus 1.
This, yeah, this is minus 1. But this part is plus 1. The complex, the inside, is complex is plus 1, right?
Plus 1.
So what charge of the iron? So this is minus 1. And here is 2.
I said 2 plus. Oh, 4. 2. 4 plus 2 plus.
Your answer is 2 or 4, right?
It's not charged.
There's no charge. How about that 2 yesterday? I mean, I say it's plus 2.
Okay. If it is plus 2, here it's minus 1, so it's minus 2. So the inside will be 0. But we know the inside should be plus 1.
So then it's 3. Plus 3.
Yes, 3. Okay, so now you know the answer is 3. So not why? It's okay.
It's 3 minus 2 is 1. Hence,
No, this is Eastern.
oh.
Explain why the iron in the complex is +3.
I think if the overall charge is negative, if it is -1,
Yeah.
if the overall one is +1,
Yeah.
and then the one inside there is -1, and then there are two thingies, the two there, I think that's the reason why it's +3.
Yeah, because this is -1, right? So 2, so it's -2. But the whole complex should be +1, so this guy must be +3.
Right.
Okay, +3, and this is -2, so the whole stuff, the whole complex will be +1. Okay? So in this case, here, so in fact, in this case, case 3, this is outside. Just only this part. Only this part is complex. This means because we know there are two metals in the compound, right? In the compound, and only this metal is surrounded by 6 ligands. 6 ligands, and this is just outside. Okay. So in this case, so basically we also can write like so basically, this can be written like this. K3 okay, it's like this. So, okay, so in this case, what charge of the metal? This guy. What is it? We know Cn, this ligand, the charge of this is -1. Yes. The answer is also 3. Explain why. Why the metal, why the iron charge is 3? This is -1, right? So we know this is +1, right? It's always like +1, right? So this is +1. +1, so 3 is total is +3. This is -6, so this must be +1, +3. Okay? Okay. So neutral molecule or iron having a no electron pair that can be used to form a bond to a metal iron. Okay. Neutral molecule like this. Okay, this is neutral molecule. Or iron like chloride. Okay. So in this case, these 5 neutral molecules and this iron are surrounded, coordinated to the metal. Okay. So they have no pairs, no electrons, no electron pairs. So they can be used to form a bond to a metal iron. So this bond is called a coordination bond. Okay. So we know this is, so in the complex, the center is metal, and the metal is surrounded by ligands. So ligands can be mono-density ligand, or bi-density ligand, or poly-density ligand. So what's mono-density? Mono-density is with one bond, just form one bond to a metal iron. The ligand can also form 2 bonds to a metal iron. So it's called bi, bi is with 2, right? Bi-density ligand. Or more than 2 bonds to metal irons is called poly-density. Poly is with many, okay? Poly-density ligands. So in these 3 samples, for example, this guy is mono-density. Okay, chloride is also also a monodentity, because they only, each of them only provide one pair, one electron pair. Okay, but for En, we will see what's En. It can provide like four, like it can provide two pairs electrons. So En is a bi-identity ligand. Okay, for example, this is En. Okay, so we can see the En is this is amino, this is mono. En is called ethylene diamine. Ethylene diamine. Ethylene, we know this is ethylene. Okay, ethylene and the diamine. This is amine, right? This is nitrogen. There are two nitrogen. So in this ligand, there are two nitrogen atoms. And we know each nitrogen atom has one pair, right? One lone pair. So this guy, these two electrons, it doesn't work. Okay. So these two electrons can be shared by metal and nitrogen. Okay. And here is another one. So this nitrogen also can provide these two electrons. So this ligand forms two covalent bonds with the metal. Okay, so this guy is called a bi-identity ligand. Bi-identity ligand. Okay, but for this ammonia, it only has one nitrogen. It can just only form one bond, one covalent bond with metal. So it's called monodentity ligand. Okay. So here we can say the ligands may show different coordination models with the metals. For this ligand, it can form two bonds, but for this ligand, form only one bond. Okay. So this is about the ligand, the types of ligands. Okay, this is a ligand which can form more covalent bonds with metals. So it's called EDTA. So EDTA is ethynyl diamino tetraacetate. Ethanol is like this part. For example, the structure of the molecule. This is the metal. Okay, this is metal, and the outside is one EDTA. It's only one EDTA. So the EDTA structure is like this. Ethanol, this is ethanol, right? And then these two carbon diamino has two nitrogen. Okay, and each nitrogen has two acetate. So this nitrogen has 1, 2 acetate, and this nitrogen has 1, 2 acetate. So it's tetraacetate. Tetra it means 4, right? So in this molecule, there are two nitrogen atoms, and also it has 4, 1, 2, 3, 4. 4 acetate groups. So each acetate group can provide one oxygen to form the covalent bond with metal. So in this structure, 2 nitrogen form 2 bonds, right? 1, 2. 4 acetate form 1, 2, 3, 4. So how many bonds in the compound? 4? 6. Yeah, 6. So this ligand can form 6 covalent bond with metals. So this is polydentity ligand. Okay? Or you like it, you can also call it a hexane. Identity ligand. Hexane means 6. Okay. So any question for this? Okay. So from here we can see the ligand can be very complex, can be very complicated, and they can form very complicated, complex with metal. Okay. Okay. Now here to show how to name the coordination compounds. So for example, how to name this compound. So because this compound includes 2 parts, right? One is complex, metal complex. Another is areas. So for the metal complex, it can have plus charge or minus charge. For example, in this case, the complex has plus charge, right? Because the outside is an area. Okay. So for this compound, how to name it? So basically, there are some rules. First, cation is named before the area. So in here, what is the cation? Which part is cation? Which part is area? So in this compound, so which part is cation? Which part is an iron? Yes, an iron is chloride, right? Cation is a complex. The complex is cation. So the cation is named before the iron. So chloride goes last. 2. Ligands are named before the metal iron. So in the complex part, the ligands should be named before the metal. So here, these 2 guys should be named before the metal. Okay. And 3, the prefix mono, di, tri are used to denote the number of simple ligands. So for example, in this there are 5 amine. So we call it pentamine. 4. The oxidation state of the central metal ion is designated by a Roman number. Okay, like using this. Copper has 3 plus 3 charge. So use this to show its oxidation state. 5. When more than one type of ligand is present, they are named alphabetically. For example, amine and chloride. Amine should be before the chloride because A is before C, right? A is before C. So the name of this guy is pentamine chloride, cobalt chloride. So here we can see the cation should be before the anion, okay? And in the cation, the ligand should be before the metal. For the ligand, if there are more than one ligand, like here is 5, so we should using some prefixes. Okay. And for ligand, A is before C, so this guy should be before this guy. Yeah.
Like I have a question for the metal ion in the complex. How can you tell the oxidation state? Like for example, that.
The oxidation state, right? Yeah, of course, you should determine. So you should. So do you remember we also learn how to determine the oxidation state for in a compound. In a compound, so for example, the same way like this for the chloride, basically it has -1 charge. Okay, and we know this is neutral. So here, 1, 2, 3 total there are 3 chloride. So 3 chloride is -3. Okay, so the carb should be +3. Yeah, so before you learn the compound, you should think out the charges of the metals and just using the way we learned before. So for like chloride, like water, okay, be neutral, right? And the chloride and fluorine, and they are -1. And oxygen basically is -2. Yeah. So you should think out the charges of the anions firstly, and then you can get the charges of the metals. Okay. Now question. How to learn the following coordination compounds? Who's that? Yeah, A, how to name it? You are better than no, you are the first one. She will get the second one. You don't know? Okay, so just according to the rule, cation is named before the anion, right? Okay, so which one? Which part is cation?
No, it's the inside.
Okay, so anyone want to help me?
Yes.
Hey. Yeah, the complex is cation.
Yes.
So you should learn the complex first, right? So and in the complexes, the metal should be before the ligand, or the ligand should be before the metal. Ligand are named before the metal. Okay, so here we should name the ligand firstly, right? So how to name the ligand? Yeah, hex water, right? So basically, water we call the echo.
What? Echo.
Echo. Echo. So hex echo.
Aqua.
Called? Yes. Okay. So the first one like hex echo called bromide. You don't have to 3 because this is not ligand. Okay, this is not ligand. If the ligand, we must say using prefix to tell to give the number of ligand, but it is the bromine is not ligand, so you don't have to write 3. Okay, have a short break.